right, well, welcome everybody to Solar Noon Tuesday. And basically the format of this conversation program is we do a quick recap of what's going on in the world of PV solar for the week so that you can keep up to date, not miss anything that might be happening in this dynamic industry. Then I try and highlight some of the upcoming webinars, events, things of that nature that cross my desk. And then we focus in on a topic to do a little bit of a deeper dive. And today I'm going to focus on microgrids. What the heck are they and why are they going to be increasingly important to our society and to this industry? So let's go ahead and jump on in. The news of the week for March 17th. And I will say that we do have a sponsorship arrangement. Sponsorship, that's a strong term, but an affiliation with the American Society of the American Solar Energy Society. I always want to do that backwards. So if you're interested in finding out more about that group, it's at asis.org, and would encourage you to go in and look at that. So Silfab has announced that they are going to be working in arrangement with SolarCycle to use recycled glass as a component of their new solar panels. Silfab is one of North America's leading solar manufacturers. And so SolarCycle has announced that they're opening up a recycling plant there in Georgia, and they're going to take glass from damaged and old solar panels and turn them into new solar panel glass. And of course, their anchor tenant for this operation is going to be Silfab at their plant that's located in South Carolina, which is about 300 miles or so from this facility. The officials from the company, they argue that by doing this, they're going to save about 30% of the carbon emissions as opposed to using fresh new glass in the manufacturing process. And they're also going to save about 50% in carbon emissions for transportation because these factories are fairly closely co-located. The New York City Council has put forward a proposal to mandate solar on city-owned buildings within New York City. This proposal was put forth at the end of February. They're anticipating installing about 100 megawatts of solar capacity within the city itself. It aligns with the city's new Green Economy Action Plan that was announced last month. And the goal of this plan is to reduce cost for the city, of course, also to reduce the carbon footprint of city operations, and to make the city's energy system more resilient as a result of that. Fronius, one of the leading German manufacturers of inverters, has announced that they're going to be increasing their materials warranty up from 10 years warranty to 12 years. And then they also stated that you can buy a extended warranty from them, taking it up to the full 20 years. I suspect this is because they're wanting to compete primarily in the residential market with Enphase and with SolarEdge, both of which have warranties 20, 25 years. I think Fronius is probably at the moment in the residential market, probably the fourth inverter. I'd say Enphase first, SolarEdge second, SMA third, and then Fronius is fourth in that ranking as far as capacity. The first U.S. offshore wind farm has begun production. I find this funny because, of course, certain candidates have been saying wind turbines have been killing whales for a while. Well, we haven't had any. So this is the first operational wind farm that is going to be offshore here in the U.S. It's located about 35 miles off the coast of Long Island. Consists of about 12 wind turbines with a generating capacity of around 130 megawatts. Construction of this facility began in 2022, February of 2022, and it is just now starting to generate some electricity for New York City and the surrounding communities. That's primarily where it'll be used. New York Governor Kathy Hochul has announced, Hochul has announced that there are 2 additional sites that are approved and construction will begin shortly in the same general vicinity. And they will increase the amount of capacity dramatically, about 12 times, 13 times the size of the already installed system. These are the Empire Wind 1 and the Sunrise wind projects. And combined, they're going to have a generating capacity of around 1,730 megawatts at those facilities. And they're claiming it's going to pump about $2 billion in development money into the local economy there. IREC has announced, and IREC is the Interstate Renewable Energy Council. They have a grant from the Department of Energy to assist local governments in that want to expand the EV charging network within their jurisdictions. Now, this is selected governments. They're actually the grant covers work in 5 states. These states are Colorado, Virginia, Michigan, Minnesota, and Ohio, and then selected portions of Texas, California, and Illinois. And this is called Charging Smart. And the purpose of this grant, they will give free technical assistance to these governments. And this is kind of a big deal because oftentimes the governments don't really know how to get started and don't have the resources to get the project underway. So they can get some of the interconnection issues, utility issues, siting issues, permitting, all of these kind of concerns, and then go out and try and get some grant money because they have a basis to build that on. So again, this is a free service from IREC to local governments within those jurisdictions. And I found this one interesting. Carhartt is promoting a line of UV rated shirts, jackets, pants, gloves. And they've actually set up a partnership with Sunrun, and Sunrun is the largest solar installation company in the United States. They're outfitting their 5,000 technicians and installers with some of this UV resistant clothing. UPF is the rating for this kind of clothing. It stands for ultraviolet protection factor. And you would think, your shirts, clothing actually protect you from ultraviolet. Although it turns out that like a normal cotton t-shirt has a UPF rating of about 5, which essentially means that 20% of the ultraviolet actually goes through the shirt and hits the skin. So it's not complete protection. So these highly resistant clothing, they claim a UPF rating of more than 50 plus, which means that it's going to block 98% or more of all of the ultraviolet, so it doesn't penetrate through the clothing to the skin. So that's that item, and that was the news. Kind of a slow week in news this week, but those were the items that I popped up on my screen. Anybody have anything they want to add to this that came up in your world before we move on to the webinars and the like? Give you just a second there, or you can jump in as I'm doing the webinars. Okay, so the announcements for this week, the NABCEP conference in Raleigh, North Carolina is going on as we speak. So if you're not there, you're probably not going to be there. So anyway, that's an annual conference that happens March 20th at 1 p.m. There's going to be an interesting webinar on photovoltaics or floating solar. This one's put on by Renview. It's at 1 p.m. on the 20th. The apprenticeship and workforce development webinar on the 20th at 2 p.m. It's called a power hour. I think it sounds a bit more like a networking thing, and it's put on by CEA, the Solar Energy Industries Association. And I think it's targeted towards Northeast United States. So you can jump in there if you're a CEA member. March 21st at 11 a.m. There's a webinar put on by Reuters about the role that corporations and financial players have in clean energy development. The 21st at 2 p.m., there's from Solar Power World, one on data at the utility scale, the use of data. Then there's a green workforce discussion put on by IREC, March 21st at 2 p.m. I've attended some of these, and they're more polling conversations between educators and some of the installers, what you need in order to develop a workforce. March 26th at noon, all these times are Eastern time. Preparing your community for solar. Now, this is put on by the Energy Coalition of Ohio. I suspect this is sort of as a result of some of these no solar on prime farmland initiatives. So they're basically saying, how do you set the groundwork so that there is less resistance to solar when it becomes a thing in your community? March 26th at 2 p.m. Eastern, permitting and inspections for EV charging and solar and storage. And this is another IREC. This is another CEA, and it's navigating consumer protection issues. So that's March 27th at 3:30 p.m. April 2nd, if you're in Pennsylvania, CE is doing one on Pennsylvania's net metering. This is a 10 a.m. webinar. So you can see there are a lot more webinars happening all of a sudden. ACES, the American Solar Energy Society, will be having their annual conference in Washington, D.C. at George Washington University, May 20th through the 23rd. So I'd invite you all to participate there. June 12th through the 13th, Solar and Storage Summit in San Francisco. And then we will shamelessly plug our own classes and online training at solarpvtraining.com. So we have some things going on right now that you can still jump into if you're a mind to. And those were all of the events and webinars and things of that nature, conferences that I was aware of. Again, I'll give anybody else who has something or an announcement they'd like to make an opportunity to jump in. Let's see. Yeah, Albert, you're muted, Al. There you go.
Yep. So my solar system was installed in 2019 with a SolarEdge string inverter. And SolarEdge is no longer supporting, as of April, the middle of April sometime, the 2G cellular connectivity to that inverter, which is how the app gets its data. So I talked to my installer, and my simple solution is just simply to run a hard wire down to the inverter, and evidently there's a place to plug in the hard wire from my modem directly to my inverter. The alternative would be, I guess, Wi-Fi. And I wondered if anyone else is dealing with this issue.
Okay, let's see if anybody have any experience with SolarEdge on some of the older units. I know that Enphase is dealing with something similar. You know, they actually now in their systems require both Wi-Fi and cellular as part of the connection for your data. And I know with their latest set of products, they've updated and moved to a hardwired connection between the components. Before it was a Bluetooth connection, which then makes backwards compatibility impossible. So basically you're dealing with either all new components as part of the new system because they're communicating between each other differently, or if you've got a legacy system, you're going to have to go out and buy some old components if you have to replace something, which makes that tough. But I hadn't heard that the 2G, the new system won't. What is it requiring? Is it requiring like 5G or you said it's hardwired?
Well, my solution is to hardwire, but otherwise they require you to upgrade the inverter to 5G, I believe is what they're saying. But, you know, it makes no sense because with a hardwire, you never have to worry about it again. Whereas even if you upgrade to 5G, it's just a matter of time until that becomes obsolete too.
Yeah, they're talking about 6G and all that. So yeah, I'm surprised that it doesn't already. I'm showing my ignorance about how the communication system works in a Solar Edge system. Anybody on the call? Have you guys installed Solar Edge and run into the communication issue? Doesn't it wirelessly connect into a modem anyway?
No,
Oh, you've
no,
got it.
there's no Wi-Fi connection at all. You can upgrade the inverter somehow to add a Wi-Fi connection, but then you're dependent on the reliability of Wi-Fi in your house, which in my case is not great.
Yeah. Yep, I think that's why Enphase requires that you have both, because one of the concerns there is the Wi-Fi can be spotty, but also then if the grid goes down, typically so does your Wi-Fi, but the cellular modem is supposed to be a bit more resilient. All right, well, I'll take a look into that and see what if there are other options. Do you happen to know, you said hardwire in, is there an Ethernet port there then for the Wi-Fi connection?
That's my understanding. Um, and you just plug the other end into your modem.
Okay, well, you could just get an extender, plug that extender into it, I imagine, and that would work, so you wouldn't have to hardwire all the way to your modem. You
But
know,
it's real simple for me because my modem is directly above on the first floor, and my inverter is right below it in the basement, so it's real easy to get down there.
oh, okay. All right. Okay, anything else anybody wants to bring up before I jump in? And I apologize, I just noticed when we went into this that I had it in Brady Bunch mode. So probably most of the first slides in the recording are going to come out with us all sitting side by side. Last Thursday, March 14th, German-based. I just lost that. And all right, I won't be able to see that. All right. Anyway, let me jump into the topic du jour. We're going to be talking about microgrids, and part of the reason, just to let you know why this sort of came up on my radar this week, is I'm involved in a development of, but just at the very periphery. They were wanting some advice about solar and how that's going to deal with it, how it's going to integrate in. But this is a interesting development where there's going to be residential, there's going to be commercial, there's going to be industrial. They're looking at a rail spur to come in, and they're just trying to get a sense of how all of this is going to work. They're thinking about putting solar on different buildings, but also a larger solar array, perhaps an agrivoltaics thing. So they're kind of open to a lot of ideas. And it struck me that microgrid for a development of this nature made a lot of sense. So I wanted to jump in and just say, okay, well, how's that going to work? What are the impediments? How do we go forward to set such a thing up? So I think before we talk a little bit about microgrids, should probably mention that how the grid actually works today. So if you look at the typical grid configuration, there is a centralized generating facility. Now that could be a coal power plant, it could be a gas power plant, a nuclear power plant, or increasingly a wind farm or a big solar utility scale solar. So that then leaves that power plant and it has a step up transformer normally, because that has to be transferred into very high voltage. The reason for the high voltage is because as electricity travels over distance, thing called voltage drop, which is the result of resistance. So you begin losing voltage. But the amount of voltage that you lose is kind of linear. You know, it's like, okay, let's say we lose 100 volts per mile. I don't know if that's realistic or not, but just say it is. Well, if you start out at 200 volts, 1 mile later, you've lost half of your electricity. But if you step it up to 700,000 volts, 1 mile later, you've lost 100 volts. Not a big deal, not a significant proportion of the electricity. So for those very, very high voltage power lines, the transmission lines, and you see those if you're driving along the highway somewhere, they're the very tall ones. They can be transmitting at 765,000 volts or 500,000 volts or 345,000, 230,000, 138,000. So those are kind of the flavors. And obviously, the further the distance, the higher the voltage is going to be, so that you avoid losing, you want to lose as little of the power going from the generating facility to where it's going to be used. And that could be as much as 300 miles. I was looking to see how far it is from our office to the generating plant here, and it's like 144 miles. So it's quite a distance. Then this power comes in and it goes to a substation. And at the substation, it steps down. So it goes through a step down transformer. And at that point, it's reduced down, could be reduced down to 26,000 volts or 69,000 volts. There are customers, large utility scale, large industry customers that may need that much power, that high of voltage power coming in. That would be referred to as a sub transmission customer. Then you would go to what they call a primary customer. So typically those lines that you see running down the roads in your city are going to be either at 13,000 volts or 4,000 volts, depending. And so there are primary customers that tap directly into that. And then there are secondary customers like stores and residents that tap in at the 13,000 volt or 4,000 volt lines. And if you look at a typical telephone pole or electric pole that's out there in your neighborhood, this is really what you're seeing there. There are different levels of transmission lines. The ones at the very, very top are typically going to be the primary wires, and those are going to be the 30,000 volt or the 13,000 volt wires. Then they're tapped into, and you'll see those little canister transformers up on the pole. They're taking from the primary and feeding the secondary wires. And those secondary wires in a residential neighborhood are typically going to be at 240 volts. And those are the wires that get tapped in and then run directly to the different houses in your neighborhood. So those are at a lower level typically. And then there's usually some wires that are quite a ways further down the pole. Those are going to be communication wires, cable television, telephone, if there is such a thing out there that's hardwired anymore. But those are going to be non-electrical wires, and they're usually significantly further down the pole. So that's what you're seeing when you look out there in a typical US overhead wire system. It's kind of nice when you're looking around and you're able to identify what's happening there. So then what is a microgrid? And why would we even want such a thing? Well, the deeper I got into this, the more it felt like if you look at a microgrid as just a bigger residential system, it's kind of easy to conceptualize what you could do, why you would do it, how it would work. So if we look at the microgrid here, normally you're gonna have some sort of generating capacity, some local on-site generation. It could be a big solar array, or it could be multiple smaller solar arrays. It could be wind turbines. Who knows what else there might be. That's typically what we're going to see. And then there's storage, perhaps, maybe not. And again, superimpose in your own mind a home. You've got a solar array on the roof. You may or may not have storage there. You're tying into the grid. There's some sort of centralized controller, some sort of switching device. And if we just sort of look at it like an AC coupled or a DC coupled system in the world of of residential solar. You've got solar on the roof, you've got a battery backup, and then you've got a smart switch, something where everything is connected into. And then from there, it goes to loads. It could go to critical loads. It could go to all of your loads. And the loads in a microgrid are going to be dealing with like transportation. Again, in a home, that might be an EV charging station. And then you've got, other, again, in the home, I may be stretching this analogy way too far, but you've got your refrigerator and your furnace and all of these loads. Some are going to be critical, some are not going to be critical. Same thing in this microgrid. There are going to be stores, there are going to be hospitals, perhaps residential homes, businesses, and it has to be determined how much of that load is considered critical and how much of it is not in case the grid goes down. So what are some of the advantages? And as I'm going through this, again, I'll just remind everybody, if you've got a comment or a question, pop on in here because I'll otherwise just ramble straight through. So the same thing that you find with solar in your home. Well, one reason you install solar is resilience. If the grid goes down, I would like to have power. Perhaps I'd like to power the whole community, all loads, or perhaps I just need to worry about critical loads. And in a development or a community of this sort, perhaps some of the critical loads would be your water system, so that there's pressure and pumping, your communication system, hospitals, emergency shelters, or perhaps your loads are everything, in which case you've got to build enough battery backup, enough supply to get you through that. So it's simply a matter of cost. How much are you willing to spend and how much of the load is considered critical? You're looking at lowering energy costs. Once again, if I'm installing a solar on my home, I look at it and say, okay, I've got resiliency now. I've got a battery backup. I've got this. But I also, over time, it's going to pay for itself. It's going to offset the cost of my electricity. Same thing in a microgrid. Within this community, we're going to offset the cost of electricity from the grid over time. And we're seeing a lot of volatility in pricing within the grid. So that might be increasingly important. It can also deal with time of day pricing issues. So you can use local resources to offset it. You can do a lot of things centrally. Now, the question is, if it were a city, this would almost be a municipal power system. But if it's just a corporate office park, or perhaps a university campus, or a school system with multiple buildings, something like that, that's where the microgrids really come in. It does, in fact, strengthen the grid. The grid is hanging by a thread, and while there's a lot of money being put into upgrading transmission, upgrading distribution, we're dealing with the legacy. They talk about the fallacy, or the paradox of the commons, where essentially there's shared infrastructure here. So if not one person's in charge, then nobody's in charge. So utilities have a history of saying, how can I stretch this out, make profits this quarter, and delay repairs, delay expansion, delay all these other things out there. And so we're seeing a grid that's really stretched. And we're also looking at adding a lot of capacity requirements to the grid. We're wanting to electrify everything. That's a buzzword within the environmental community. And transitioning to clean energy. Well, we're looking at transitioning transportation to electricity. We're trying to phase out natural gas in appliances and the like. All of these things keep adding more and more demand on an already stretched grid. And it's going to cause some problems. Plus, with global climate change, we're seeing increasingly severe weather events, which again cause problems on the grid. So if we can create our own smaller grids, tap into this existing grid, we can offset some of these necessary expansions and repairs because no longer do you have to transmit power 300 miles from a power station to where you're using it. You're developing it and using it locally. And then you're just doing the over under. You're sending a little bit back. You're pulling some when you need it. Again, the analogy is true. Again, just like a home, where you tap in the net metering, you hope over the course of the year you net zero out, but you will have back and forth transmission, but not the same level that you would need if everything was coming from the grid. And it is much more secure. We have not really seen yet, or at least it hasn't been publicized, cyber attacks on our infrastructure. But anyone who knows anything about this knows they're coming. They're probably happening all the time. We're just not aware of them. But once we get one that's catastrophic, we're certainly going to be aware of it. And if you have distributed energy sources, microgrids, individual homes, you've dissipated. There's no longer a central point of vulnerability. So this is definitely something that's going to become an increasing issue as our world just becomes more digital and less secure. All right, so talking a little bit about energy resiliency. Yeah, there's a comment there that military bases are certainly well along under doing microgrids, which makes perfect sense. I mean, they have to be, resilient. Hospitals would be another one of these medical centers. Currently, they typically just have big backup generators, but that's kind of a clumsy way of doing this. We have better technology now. So what are some of the resiliency issues that we're facing? Well, you can see that major power outages or power interruptions happen increasingly or sporadically, depending. But I think the trend is upward over time. In 2022, there was an average of about 5.5 hours, I think, nationwide. Of most people experience 5.5 hours of downtime, power outages during the course of the year. That may not sound like a lot, but of course, if you're on a kidney dialysis machine at the time, it's a big deal. So it just depends how critical this infrastructure is. How critical is the resiliency? A lot of these companies, if you're doing financial trading or the like, I mean, that's real money when you have downtime, and it's not necessarily spread out evenly over the geography of the country. You can see some places like Florida experience many more hours of downtime, almost 20 hours a week. West Virginia, Vermont, Maine, those are all there. The frequency, Alaska, the time that's out is not as much, but it's more often. So those are we can pretty much intuitively know that having power outages are going to be something that having some sort of local system is going to at least mitigate. So then you have to determine, as part of this process, just what are your risks. So the Department of Energy, through Sandia Labs, has a nice document that walks through what they suggest are the steps of developing a microgrid for your campus, for your project. So some of what they want you to do is just say, all right, so what is this thing that's driving the idea that a microgrid is necessary? And I've touched on some of them about just the normal threats of, living in a world that's got periodic issues that cause the grid to go down. Are there specific threats to this particular development? Are there specific critical loads that are a big issue? And what are the goals? I mean, what is your goal? 100% uptime? Minimize these outages. So again, the more resilient it is, the more it's going to cost. And then once you've done this analysis, you want to then sort of figure out what you're going to have to do to meet those goals. And then an interesting thing I found in their step-by-step process was they said, you know what, look at all the alternatives. You're talking about putting in a microgrid, but maybe there are better, more cost-effective alternatives. The analogy I was thinking about is if you're thinking about installing solar, well, shouldn't you look at energy conservation first? How can you reduce your demand, your dependency on electricity, insulation, storm windows, all of those kind of things, and then you just evaluate those alternatives and put it into your planning document. All right, let me take a breath here and see as we're moving forward if anybody's got a question, comment. Give you just a second there. All right, so then once you've made these kind of very 30,000-foot examinations, then they suggest that you do a preliminary design. And a lot of their documentation was like, get 20% the way there. Don't worry about all the finite details in it. Just try and get there. So this design should look at safety. You want a system that it's not going to kill people, and hopefully that's just built into the batter there. So it's got to be safe. It's got to be secure. Then and the security is dealing with what kind of software do you have that's managing this system? What kind of physical protection and infrastructure is going to be there to keep people from, it might just be as simple as don't drive a car into this control board or something like that. It's got to perform. How much is it based on sustainability? That's part of these goals, is to make this system sustainable and cost effective. So that's kind of their rubric to build into everything that you're doing. And then you define some of your system characteristics, your goals. We talked about that in just a minute ago. In that first step is just saying, okay, what kind of resiliency goals do we have? What are our what's the available infrastructure that may exist? If it's a brand new thing, well, if it's a brand new development like the one I'm working with, then there's no limitations at the moment. But oftentimes these are retrofit kind of situations. Then what kind of regulatory policies, requirements, jurisdictions, all these fall into. And then it talks about looking at what are the threats, what are the design threats that you're going to be addressing. And they've sort of broken these down into three main categories: natural threats. These are, obviously weather events, extreme heat, flooding. Hopefully here in Ohio, earthquakes, tsunamis are not a big deal, but wildfires could be, drought could be. So all of these are natural, and we know they're happening more and more often. Then there's intentional threats that are direct: cyber attack, I mentioned there. Electromagnetic attack, I think you could put that into natural as well. If you're not familiar with, and now what is it, EMT? Anyway, the periodically through solar activity, we get these electromagnetic disruptions, and there were due. I know there was a big one in the 60s or the 70s up in Montreal that took out the electrical grid up there. There were one that they like to talk about in the 1880s that, literally like blew apart the telegraph systems and was like blowing up components. And our systems are a million times more sensitive than that. So if we had one of these electromagnetic storms, we could see incredible damage, and the damage would be months to recover from. Not days, not hours, but literally months to get over. Then there are some, structural built into just our economy and our society. There's economic market shocks, regulatory policy changes. We see this all the time. Aging infrastructure, we're dealing with that. I think that's going to be one of the major threats to our grid. There's, the geomagnetic pulses, as I talked about. Capacity constraints, as if we were all of a sudden dumped electric vehicles in this mix, that's going to double our electric requirements. Who's going to do this? It takes 5 years right now for a large system to get approval by for interconnection. We're not going to respond quickly to this, and I don't know that people. It's like each part is looking at each part, and I don't think they're looking at the whole. So this is going to be a big issue. Workforce. Well, we've talked about in past sessions, we need to triple the workforce in solar just to meet the current goals. Where are these people going to come from? Because when I talk to educational people, they can't get enough people into the trades as it is. And we need plumbers, we need electricians, we need welders, we need all of these skilled trades. Where are these folks going to come from? Supply chain disruption. We saw a lot of this during COVID. We've seen China dominating the semiconductor and the silicon industries, and we're becoming increasingly dependent on that. We're trying to address that with some of the policies, but frankly, a 10% tax credit by an American does not help a lot when China can undercut your price by 30 or 40%. I think we're going to see we're still dependent on China, because if I'm making a rational decision and I can save 10% by buying American or 40% by buying Chinese, more times than not, you're going to end up buying Chinese. Walmart's a good example of that. And just, people make mistakes. So those are some of the threats that we're dealing with. Then when we're talking about identifying critical loads and the infrastructure, well, in your home, it's kind of easy to identify what these things are. You just say, I want my furnace to run. I want my well pump to run. I want my, sump pump to run in case there's a disaster. I need my modem to be operational. I need some lights. Well, now put this into your community. Do you need your sewer system to work? Do you need your water system to work? Do you need your communication systems to work? What about transportation systems? All of these things are integrated in with the electrical grid. So how much of it do you use? How much of it don't you use? In a heat emergency in the middle of the summer, cooling is a big energy drain. How are you going to deal with that? So, banking and finance, I think you can throw that on the back burner, at least show my bias there. And then you need to come up with some solutions, right? Now we get into the nitty gritty. It's a little bit like the old Steve Martin thing. You can be a millionaire and not pay taxes. First, go out and make $1 million. Then don't pay your taxes, right? Well, going out and making $1 million, designing your system, this is a complex thing. So I don't want to sort of shortchange it, but it is going to be complex and not something we can really go into here in the 5 minutes or so we've got left. But I will point out that Sandia National Labs, which is part of the Department of Energy, has this online toolkit. It's the Microgrid Design Toolkit. And you can go into this, and it's quite detailed. It allows the developer to answer all of the questions, some of which I've raised here during this presentation. And it will actually begin to generate a true design. Obviously, if you're a developer or a city or somebody like that, you're going to end up enlisting engineers and designers and all of the procurement people and all of that kind of thing. It's going to be a multi-year task, but at least getting you started, this is a good tool to jump in, and I believe it's free. I don't think there's any charge associated with that. So if you've got unlimited time on your hands, you can go in and play around with that and design your own microgrid there. Looking at some of the costs, I found that based on surveys done 2018, microgrids end up costing in the neighborhood of $2 to $5 per watt, or $2 million to $5 million per megawatt. Kind of strikingly similar in cost to putting solar on your home. Again, the analogy is pretty good. So if we carry that analogy forward, you look at $2 to $5 million. Gosh, that seems like a lot of money for a megawatt of power. Although, as part of this subdivision we were just talking about, they were saying, well, we extended the water line and the sewer line down this road, and that cost about $1 million. So the million here, a million there, and suddenly you're talking about real money. So I think if you say $2 to $5, thinking about the same thing, putting solar on your home, yes, it's a high upfront investment that you might not have to make if you are dependent on the grid. But over time, just like installing solar on your home, over time, it will pay for itself. And are you willing to put in that investment and develop this resiliency within this community? Sometimes you just have to. You don't have a choice. The loads are so critical. But other times, I think if you really push the numbers through, it's going to make financial sense as well. What are some of the types, configurations, and the like? Well, I guess all microgrids are not developed equally. There are large ones, there are smaller ones, they're in front of the meter, they're behind the meter. Typically, the larger they are, they're going to be not owned by a single customer, but they're going to be attached to the grid in front of the meter. And then I thought this diagram was kind of interesting, where you can see that they can get increasingly complex. There can be multiple sources of generating capacity, lots of smaller solar arrays, wind turbines, whatever. There can be owner-owned generating facilities, like the little house there in the green that's got its own solar array. So all of these things can be integrated, excuse me, into the system, and just like you could do with a multi-building property of your own, behind the meter there. And then there are, again, similar to what we see with residential systems, there's just simple grid tied systems where it's a grid backup and just uses critical loads, or it's always islanded. Essentially, you're building your own standalone microgrid, not even connected to the grid. And I know Devanand, who's on these calls periodically, was talking about in Trinidad, they were not allowed to connect to the grid unless they get specific approval. So you might want to just create your own electric system. Obviously, that's going to be the most expensive. And then there's hybrids, where you're using the grid, you're not using the grid, depending, you're managing it. It's like an AC coupled or a DC coupled system on your home. Okay, that's a quick overview, perhaps a little bit deeper than we liked. Everything you ever wanted to know about microgrids, and some things you didn't want to know about microgrids. Anybody have any comment there? I think we were about 2 or 3 minutes before we have to call it a day.
Hi, Jay, Devanan here.
Yeah.
Hi, Red sir. There's a very well-known software called Homer. It's quite recognized in the industry for microgrid optimization and development. It's a software that if anybody wants to check it out, it's something they can look at. Homer.
Homer, like
Yeah.
like Homer, the Greek author. Yeah. Okay.
Yeah.
All right. Well, that's good to know. Anybody else have any comments? Somebody's saying let's just microgrid everything. I think that's where we're moving to. I think we're talking about individual systems on individual houses. Why not just extend that outward? Have neighborhood microgrids and have community microgrids. It's kind of a logical extension. The only thing holding us up is money. That's a problem. So, all right. Any comments? Otherwise, speak now. All right. Well, we'll see you guys next week. I've got a couple of suggestions that have been coming into me. One talking about how come the soft costs in solar are so high, And I thought I'd also maybe do a deep dive into just sort of what I touched on here today, which is we're expecting a lot over the next few years, over the next couple of decades from our electrical grid. Are we prepared for this? I mean, I don't think we are. But what are we going to be dealing with? What are these? Where's this impending disaster? So, all right, I'll see you guys next week.